Okay, here's example 2 from class 20 for rigid body, Newton's second law. A uniform beam of 15 feet long and that weighs 500 pounds. If one of the cables breaks, determine the tension in the second cable the instant after the break occurs. Ignore dog's weight. This is a very common type of problem in the very beginning of rigid body acceleration. So just welcome to the club. I decided to include it because it gets asked a lot of times. You'll see. Like in the PhD qualifying exam, this was a problem that was commonly asked that you were told to know how to do. Well, it wasn't like the committee told you how to do it, told you that you knew how to do it, but former fellow students who had taken the qualifying exam said you better know how to do this problem because they like to ask it. So we draw the FBD and the IBD, and let's apply the forces right here. So I'm going to go, this is the force due to tension at A, and then after the thing cuts, there is no force of tension at B. And here we have a weight. We have the weight of the thing, so W right here. And so there's no other forces acting on this. In terms of accelerations, we know that the bottom or the center is going to accelerate. So it's going to be the mass times the acceleration, and let's say that's the acceleration in the y direction because it is. And then we kind of know that it's going to be accelerating this direction. We can just tell. So it's going to be I times alpha, right? And I think we have everything covered. In the x direction, there is no acceleration, and we know that because there are no forces. Let's say, what just happened here? Okay, that's fun. And so we could take the sum of the forces in the y direction are going to be equal to mass times acceleration in the y direction. And and we will say that that's going to be positive right there. So we'll say that FA minus W is going to be equal to a minus MAY, right? And then we could also say that the sum of the moments, and now it might be better for us if we took it, let's take it about the center right here, okay? So we're going to take it about the center because that's a good spot to start with. And we'll say that the sum of the moments about, and I guess I decided to go G right here, where that turns out to be, that's what G is right there. It's going to be equal to the I right here, I alpha, right? Or we could say IG if we want to. A lot of times that's what we'll do. And based on what I actually see here, we have the only force that it will be about G, right? Because W goes right through it, is going to be a negative FA times the length divided by 2. Right, so let's say 15 over 2, right? So it's going to be this distance right there. And there are no other moments being applied to this, and so we're going to have negative I and times alpha, because those are also assumed clockwise. But even if we hadn't assumed clockwise, we know now that it's got to be clockwise. All right. Oh, excuse me. I do this next. I say an I bar is going to be, this is, we could treat, we don't know this dimension, so let's pretend like it's just thin. And we can go 1/12 ML squared. So make sure that we turn these all into slugs. So it's 500 divided by 32.2. And then the length of the whole thing is 15 squared. So we're going to end up with 291.1. you could actually say these in a couple different units. I wrote down that they are pound feet second squared. The book often will do that. I just say that they're slug feet squared, because that's what mass times length squared. But you could also just, without dividing it by anything, just recognize that a slug, well, actually, this is the way that I always think of it. F equals ma. So I say that a pound is equal to a slug foot per second squared. But you could also say that a slug was equal to a pound per foot second squared, if you will. So that's how you could see that you might get a pound. Like, this could also be a pound foot second squared. Just be on the lookout for it. Some books do that. It's just weird. You might see it in the example problems in the textbook. So what we could do is we could plug this guy back into here, and what we're left with is FA times 7.5, right, is equal to 291.1 times alpha. And I guess I could go alpha B. Did I call it alpha B anywhere? No, I just left it there. Okay, that was the previous problem. All right, so here's an equation, and we could plug this back over into here. Let's see, we could put in the numbers FA minus 500, right? 500 and equal to minus 500 divided by 32.2, and then times IA. So we have two equations, but we have three unknowns, right? So we could call this like equation 1, and this is equation 2. It's because on the left and the right. And I could probably write out what that 500 divided by 32.2 is, but I didn't. Now we use kinematics, and from the kinematic relationship, I actually drew the thing out right here. We know that alpha is going to be related to that A in the y direction here by that AY is going to be equal to 15 divided by 2 times alpha. And which one did I substitute here? I decided to substitute that alpha was equal to AY over 7.5, right? So I'm able to substitute that in, and now I'm able, so if we wanted to, we'd call that equation 3 if we were so inclined right here. But we could just all plug all these things into place, and what we end up finding is that if we substitute back in here, I find that FA is going to equal to 125 pounds, which is really sort of a surprising thing. And by the way, we should say that's in tension. You really shouldn't draw an arrow up and down when it comes to a tension right there, because it's all about like whether you cut and you looked at the part that's left over on the bottom or the part that's up on the top. The tension is going to be, the direction in terms of an arrow is going to be backwards or either way, depending on which one you're looking at. But then if you just write it as tension, you can be 100% sure. Now, I have messed this thing up before, and I just want to double check. But it's interesting to me, right, that it's less than 250 pounds, right? You would think that that the instant this thing got cut, that it would be 250 pounds. But it turns out it's not. This is a very interesting problem when they put springs instead, and then they cut one of the springs, because it's kind of conceptually, that spring, its force is determined by the amount of deflection that it has. And at the instant that the other spring gets cut, its deflection has not changed. So in that case, its tension is going to equal the original tension. That's really kind of crazy, right? that because it had to deform with its original distribution between the two different springs that were holding the thing, they deflected, and so that's the amount of deflection they have. And once you cut the other spring, the deflection at that instant, the deflection hasn't changed, so the force is the same. So it's kind of weird that for a cable you get a different answer than for a spring. It's really conceptually, it's difficult to try to get to accept those types of things that are true. So let me, this is going to run a little bit long here, but I just want to double check my math on these because I have made a mistake on here, and students have caught me in it in this very simple problem. I don't know why I seem to always get this thing mixed up here, but I do. So let me just write this out right here. So I had FA right here. Let me write it out this way. FA 7.5 is equal to 291.1 divided by 7.5 AY, right? And then so I could say that AY is going to be equal to, so it's 7.5, actually squared, right? Because you can move that over squared. Okay, sure. And then divided by 291.1, boom. So that's what I get, 1932 times FA. And then I say, then I plug that back up into here. And I just want to see if I get the same thing as I get 500 times that, and 32.2 divided by that. So I end up with 3.001 times FA. And it's negative, right? So let me write this out. Minus 500 equals minus 3 times FA. All right, so I'm going to bring this over to the side, so it ends up being 4. Yep, FA is equal to 500, right? And so I buy that. That 500 divided by 4 is 125. Okay, cool. There was like a sig figgy that got messed up in there because I think there was actually like 1 right there. So anyway, this is the answer. I've confirmed it. I don't know why. I've had it wrong before. I just remember that, like, and I wasn't the only one, right? It was actually somebody else's problem, and I wrote it down, and I got the wrong answer to it, and it irritated me. So let's do another example after this, and I'll record it as a different video. So thank you for paying attention. And there's Newt Dog, and he says goodbye.